So after post-processing the results, we can see the validation for our results. As initially we saw that these are the results that are given by the Euler-Bernoulli beam theory. So we can see how close are these beam theory results with results that are given by an X-Nastran. So we'll start with reaction force. So as we saw at the two ends, the reaction force was 15,000 newtons or 15 kilonewton, and if we cross check it with the theoretical results, it matches perfectly 15 kilonewton. So secondly, we'll see the shear force. Again, this is the shear force distribution. So the maximum value of shear force was about 14.75 kilonewtons. So if we see the theoretical results, it is very close. Theoretically, it is 15 kilonewtons, but this is very close enough. And you can see the distribution, or you can see the graph that we drew. And if you try to compare it with the theoretical results, you will see that the distribution is same, the sign convention might be different. So here at the left half of the beam, the shear force was positive and then it became negative, and if you see here, it was negative on the first half and positive on the other half. So the sign convention might be different, but the distribution and the magnitude will always be accurate. Same thing you can see for bending moment. So again, if you turn on the annotation, you will see that the maximum bending moment was at the center, and here also the maximum bending moment was at the center, L by 2, and its value was 22.5 kilonewton meters. So here the value is given in Newton mm. You can change that in edit post view if you go. So you have the units here. So if you change the unit to Newton meter, now you have 22,504 Newton meter, which is 22.5 kilonewton meters. So okay, you can change that back, or you can keep it. Now you can cross check the displacement. So y displacement was 0.476 millimeters, and if you check the theoretical results, it was 0.4724 millimeters. So close enough, very close. Again, for the bending stresses, you can see. So if you go to stress XX and the edit post view, you give it a maximum recovery point and node average. You can see that the value is 4.409 megapascal and at the center of the beam. So if you now compare it here, it is almost same, 4.409. And you can see that theoretically the bending stress distribution was like this: top fibers were in compression and bottom fibers were in tension. And when we saw the cross-section view at the center element and the center node, we saw the same thing, that the top fibers were in compression and the bottom fibers were in tension, right? One thing also, if you want to try, you can try multiple layouts. So suppose if I want two layouts here, so suppose I want the stress distribution longitudinal and then the cross section. So first I can go to stress XX. Again, I take the maximum recovery point and node averaging. So this is the bending stress distribution, and now if I select side by side, so I'll have two layouts. So this is the first layout, this is the second layout, and now if I try to draw the cross section view, I can draw it on this viewport. So now I have both the longitudinal view as well as the cross section view, right? And similarly, you can try using 4 views or multiple views. And as always, at the end, don't forget to uh, save the results. And thank you very much.